Okay, good afternoon class. So at this point you guys have gotten your scripts back. So let's go through the memo quickly of these papers. We will probably only finish half the paper in today's lesson. Okay. So let's go. So we are told solve for x. Okay. To solve for x in 1.1.1, as you can see, the sum is already factorized. Okay. So we got 2x minus 1 is equal to 0, so x is equal to half. Or x plus 4 over 5 is equal to 0, so x is equal to negative 4 over 5. Okay. Let's carry on. Let's do 1.1.2. Goliath, my God. You mustn't be talking now, yeah? So here people, in 1.1.2 we got 3x minus 1 into x minus 4 is equal to 16. We are not going to say 3x minus 1 is equal to 16 and x minus 4 is equal to 16. Okay? We have to get it in standard form and then factorize it again. So that of course is going to give us 3x squared minus 12x minus x is minus 13x. Plus 4 minus 16 is equal to 0. So we got 3x squared minus 13x minus 12 is equal to 0. So as you can see here people, this won't factorize. So we must use the quadratic formula. Something to note here, when you see that in the question 1, we know we must use the quadratic formula. Okay? So let's substitute it into the quadratic formula as minus b plus minus the square root of b squared minus 4ac over 2a. So x works out to be one of two values. So we're going to get 13 plus the square root of 13 squared minus 4 times a times c over 2a. So it gives you 5,12, is that correct? 5,12. And you replace that with negative. You get the other factor which is negative 0,7. 8. Okay. Is there any confusion at this point? Some of you would have only gotten 2 marks. If you do not show your substitution in this question, you're going to lose 2 marks. Okay? So you must show your substitution. Okay? In the next question, 1.1.3, we have our critical values here. It's going to be 0 and 8. As you can see, if I multiply that out, I get negative x squared. So it's going to be a frowning parabola. So you got 0 and 8. So it's linear inequality. The function has to be less than 0, which means to say it must be negative. Okay. So in other words, that is y is equal to 0. Negative is below the line, as you can see. So in other words, x must be less than 0, or x must be more than 8. Okay. Let's carry on with 1.1.4. Girls on that side, please, man. If you don't mind. Okay? The first step is to isolate the root, is to get the root on its own. So I'm going to take that negative 3x over the equal sign. So it becomes the square root of 2x plus 1 is equal to 3x plus 1. Now I can square both sides, which now gives me 2x plus 1 is equal to 9x squared plus 6x plus 1. Give everything to one side of the equal sign, so it's 9x squared minus 6x minus 2x will be plus 4x. The ones cancels. As you can see, we can take out x as a common factor, so it's 9x plus 4. Set each factor equal to 0, so x equal to 0, or 9x plus 4 is equal to 0. So 9x is equal to negative 4 divided by 9, so it's negative 4 over. And of course we need to check if both works. I put 0 in here. So 2 times 0 is 0, plus 1 is 1. Square root of 1 is 1. And negative 3 times 0 is 0. So 1 minus 0 is. So that one works. Not so. So what I'm going to do is I need to substitute negative 4 over 9 as well. If that gives me an answer of 1, then that would be a solution as well. So it's the square root of 2 answer plus 1 as I entered it into the calculator minus 3 answer, giving an answer of 5 over 3. So is that a solution? No. So I put a line through. It's not applicable. Okay. Let's look at the next question in question 1.2. The question says solve for x and y simultaneously or at the same time. So again I'm going to make x the subject of the formula. Either I can make x or y the subject of the formula. Okay? But I get over the equal sign, so I get x is equal to y minus 2. So I then take that and I substitute it into the other equation. Wherever I see a x, I replace it with y minus 2. So it's y minus 2 squared plus y squared is equal to 20. So you get y squared minus 4y plus 4 plus y squared is equal to 20. So now it gives me 2y squared minus 4y minus 16 is equal to 0. So I can use a quadratic formula, or I can divide it by 2 and then factorize, or I can just plug it into this calculator here. You've got 2 minus 4 minus 16. I made a mistake there, it must be minus 16. So we give you a y value of 4 or y value of negative 2. So what do I need to do is I need to solve for x now. So I substitute that into the third equation. So x is equal to 4 minus 2, which is 2. On the other hand, we have y is equal to minus 2 minus 2, which is negative 4. Okay. Let's carry on. 1.3. This is a giveaway. Most of you got this one right. So 4 can be written as 2 squared raised to the exponent n plus 1. 8 can be written as 2 cubed raised to the 2n. Over 16 can be written as 2 to the 4 raised to 2n minus 1. So again we need to get rid of the brackets there. Okay, we multiply the exponents. So it's 2 to the 2n plus 2 times 2 to the 6n over 2 to the 8n minus, which is 2 to the 2n plus 2 plus 6n minus 8n plus 4, which is 2. 2n plus 6n is 8n minus 8n is 0. And 2 plus 4 is 6, and 2 to the 6 is 128. Is that correct? 64. Okay, my mistake. 2 to the 7 will be that also. 60. Okay. Next, in 1.4 we are told for which values of p will the equation x squared plus x into 2p plus 4 plus 9p is equal to 0 equal roots. People, roots are dependent on what? Delta, which is b squared minus 4ac. Now, in standard form, we extract your value for a, the value for b, and the value for c in that case. So the value for a, or the coefficient of x squared is 1. So it's going to be 1 squared minus 4. Your a is again 1, and your, no, it's b squared, sorry. Okay, my mistake there. Your coefficient of x is b. So it's going to be 2p plus 4 squared minus 4. Your a value, of course, is 1. and your C value is 9p. Now multiply this out, I get 4p squared plus that times 2 is going to be 80 16p plus 16 minus 36p. So that is simply going to give us 4p squared minus 20p plus 16. So that is what delta is equal to in terms of p. So 4 equal roots. What do we know? Delta is equal to 0. So 0 is equal to 4p squared minus 20p plus 16. So I divide by 4. So 0 is equal to p squared minus 5p plus 4. So we've got p and p. 4 and 1 both is negative. So p is equal to 4 or p is equal to 1. Okay. That gets you those 3 marks there. In question 2, now we're moving on to our number patterns, or sequence and series. Given the quadratic sequence 6, 6, 10, 18. So how do I move from one term to the next? I'm adding 0, then 4, then 8. So how much are we adding there? 4 and 4. Not so. So again I must add 4. So 8 plus 4 is of course 12. 18 plus 12 is 30. So T5 is 30. Okay, we'll agree with that. In question 2.2, they ask you to determine the formula for the nth term of the sequence. So for Tn, so firstly I write 2a, 3a plus b, a plus b plus c. On the bottom up, so the general term of course is Tn is equal to an squared plus bn plus c. So I say 2a is equal to 4, a is then equal to 2. So it's 3 times 2 plus b is equal to 0, so b is minus 6. Then we got a, which is 2, plus b, which is negative 6, plus c is equal to 6. So that is going to give you negative 4, so c is going to give us 10. Okay? So that would simply give us a general term of Tn is equal to 2n squared minus 6n plus 10. Okay. And of course it's worth testing if it's correct. So I tested on term 5. The answer should be 30. If it's not 30, of course I made a mistake somewhere. So it's going to be 2 times 5 squared minus 6 times 5 plus 10. Gives you 30, so which makes that correct. Okay. Then the question says, which term of the sequence has a value of 32,010? Which term of the sequence? Remembering that is the nth term. So it's 32,010 is equal to 2n squared minus 6n plus 10. So you got 0 is equal to 2n squared minus 6n minus 32,000. Again, you can work out the factors. It will take you forever in the day. Or you can see it, it's fine. Otherwise, I use either the quadratic formula or this function on this calculator. Gives you an x value of 128 or an n value of 128, and of course a negative value, of course, which can't be the case. But of course, I write it down as well, and that's submitted at the end. So therefore, the 128th term has a value of 32,010. Okay. Then they want to know, remembering that is a general term, determine between which two consecutive terms the first term is 200. Determine between which two consecutive terms the first difference is 200. So the first difference, people, is we have subtracted 2 terms. Not so. So these are the first difference here. This is your first difference. So one of 2 ways I could have approached this. I could either work out the general term there and then set it equal to 200, then work back, 1 back. Or I can just use this here. Okay? So the consecutive terms, of course, the one term is going to be Tn plus 1 minus Tn is equal to 200. Okay? So the difference between the 2 terms is 200. So if I see an n, I replace it with an n plus 1, so it's 2 into n plus 1 squared, minus 6 into n plus 1, the other way is actually easier, come to the plus 10, minus into 2 Tn, which is 2n squared, minus 6n plus 10 is an answer of 200. So this is tidying up a bit. So it's going to give me 2n squared plus 4n plus 2 minus 6n minus 6 plus 10 minus 2n squared plus 6n minus 10 minus 200 is equal to 0. Okay? Of course that cancels. 6n cancels. 10 cancels. So I'm left with 4n is equal to, now 2 minus 6 is minus 4. That's all? Minus 4 minus 200 is minus 204, which becomes positive 204. Divide by 4 both sides, n is then equal to 51. So the first term is 51, so therefore it's between T51 and T52. Why 52? Because it's n plus 1. Okay. So it's T52 minus T51, which will give you an answer of 1. Okay. It was worth 4 marks. In 3.1, the question says prove that a plus r squared plus 2n terms is equal to a into 1 minus r to the n over 1 minus r for r is not equal to 1. That link to that proof can be found below in the description box below. Okay. We're not going to do that proof now. In 3.2, we are given the geometric sequence or series 15, 5, 3. As you can see, from one term to the next, I'm dividing by 3, which is actually a ratio. So I'm multiplying it by a third. Okay. Explain why the series converge. The series converge because your ratio is between negative 1 and 1. Okay. That is why the series converges. The next question says evaluate, determine or simplify all means the same thing. Okay. As you can see, it's going to the sum to infinity. Okay, so most of you would have linked that already to this sequence. Now say we didn't know that, or that sequence wasn't given the series. Then what we do is we then say to work out the first 3 terms, because that is the nth term. So T1 is where n is 1, the starting point is 1. So it's 5 times 3 to the 2 minus 1, which is 15. T2 is going to be 5 times 3 to the 2 minus 2, which is 5. T3 is going to be 5 times 3 to the 2 minus 3, which is 5 over 3. Okay. Again, as I said, if you don't make that link there, then that is what you would have done. So the sum to infinity is equal to a over 1 minus r. My a value, of course, is 15 over 1 minus 30. Okay. You put that in a calculator. It's going to be 15 over 1 minus a third. Gives you 45 of it. Okay, or 22.1. It's also the same thing, or 22.5. The next question in 3.3, the sum of the first n terms of the sequence is given by Sn is equal to 2 to the n plus 2 minus 4. Determine the sum of the first 24 terms. That's simple. the sum of the first 24 terms is going to be 2 to the 24 plus 2 minus 4. So it's 2 to the exponent 24 plus 2 minus 4. Oops. $67 million, 108,000, 860. Okay. Then this is determine the 24th term. So T24 is going to be S24 minus S20. Okay. Why? Because our Tn is equal to Sn minus 1. Okay. So it's 6710860 minus S23. Open brackets is 2 to the 23 plus 2 minus 4. Okay. So let us put the answer. That's the last answer calculated. Minus open brackets. So it will be 23. Is that correct? Is that right? It's going to give you 33,554,432. So that's the value of term 24. Okay. Question 4. In question 4.1, we are told that the function f of x equals negative x squared minus 2x plus 3, and g of x is equal to mx plus c, are drawn below, with g passing through E, C, and A. Okay? Then we are told A and B are the x-intercepts of f. CD is the axis of symmetry of f. E is the y-intercept of G. Okay. Put this up here. We need all the space we can get. Move this over here. Okay. First question. Number 1, we are asked, determine the coordinates of C. People, C, I don't understand why some of you got this wrong. C is a turning point. Okay, which is the x value for the, in other words, your axis of symmetry. Needs to be calculated first, which is minus b over 2a. So it's coming from f of x. So it's minus 2 minus over 2a, which is negative 1. So that gives me an answer of negative 1. What do I do with that? I substitute it into the function. So f of negative 1 is equal to negative 1 squared minus 2 into negative 1 plus 3. So it's going to be negative 1. It's going to give me an answer of 4. So C is going to be negative 1 and 4. People, this sum you can't throw that away. It's some easy ones. Okay. Let's look at the second question. The second question says, so now as you can see, I wrote negative 1 and 4 on the diagram so that I can just erase this and keep the diagram in focus. Okay. In 4.1.2, determine the coordinates of A and B. Again, for A and B, it is your x-intercept of G and F. I don't have the equation of G. Even if I had, I'm going to still work with Fy because I need to pick up B anyway. Okay? So I do x-intercept. What do you do for x-intercept? We let y equal to 0. So we got 0 is equal to negative x squared minus 2x plus 3. So I divide by negative 1. So 0 is equal to x squared plus 2x minus 3. Trinomial. X and 3, x and 1 plus minus. So x is equal to minus 3 or x is equal to. Okay, so therefore the coordinates of A is going to give you the negative 3 and 0, whilst B is going to be 1 and 0. So that's going to be 1 and that's going to be negative 3. Okay. 4.1.3 says write down the coordinates of y, the coordinates of the y-intercept of the graph of f. So in other words, it's looking for that coordinate there. What do we do for the y-intercept? We let x equal to 0. Okay, so f of 0 is going to be negative 0 squared minus 2 times 0 plus 3, so it gives me an answer of 3. Okay, so the y value is going to be 3. Or you could have just written y is equal to 3. You don't have to show that calculation as well. Yes, Michael? Okay. Again, I'm going to remove this here. Then it says, what is the length of CE? The length of CE. So to calculate the length, I'm going to use, of course, distance formula. I got the coordinates of C, however, I need the coordinates of E. Sorry, CE, not CD. Did I say CD? Okay. We need the coordinates of E. E is also the y-intercept of G. But hang on, I don't have the equation of the y of G. So I need to do that first. Okay? I need to work out the y-intercept first. I need to work out the equation of G first. So G of x is equal to y is equal to mx plus c. To calculate m, which is your gradient, is going to be y2 minus y1 over x2 minus x1. Do I have 2 points that the graph of G is going through? Yes. C, which is negative 1 and 4. And A, which is negative 3 and 0. So I'm going to get 4 minus 0 over minus 1 minus 3. So that's going to be 4 over 2, which is 2. So my equation now reads y is equal to 2x plus c. Now to calculate c, I must substitute a point is lying on this curve, which you see is negative 1 and 4. That's an x and a y. So 4 is equal to 2 times negative 1 plus c. C works out to be 6. So y is equal to 2x plus 6. So therefore E, the coordinates of E is going to be 0 and 6. Okay. So with that, I should be able to now calculate the length of CE. Therefore CE, I'm going to use the distance formula. CE is equal to, there's C and there's E. It's going to be minus 1 minus 0 squared plus 4 minus 6 squared. Okay, that's going to give an answer of 1 plus 4 is 5, so it's the root of, square root of 5 should be the length of C. Okay. I'm sure there's more ways of doing that, more than one way. You are given the exponential function p of x is equal to a third raised to the x. Write down the range of, okay, so what is the range of p of x as it stands? Y must be greater than 0. Not so, by saying that q of x equal to p of x plus 2, the graph then shifts 2 units up. So does the asymptote as well. So in other words, the equation of the asymptote is y is greater than 2. Okay. The next question we are asked, 4.2.2, determine the equation of the inverse function of p. So what do we do for the inverse function? We interchange x and 1. So then you got x is equal to a third raised to the 1. So therefore, y is equal to log x base a third Or if I had made that as x is equal to 3 to the minus y, negative y is equal to log x base 3, so y is negative log x base 3. People, both is acceptable, and it's important that you know both ways as well. Okay, because sometimes they ask you with regards to transformation geometry that comes into play. Okay, and you always get caught out here because they don't know that those two are equivalent. The next question says that is the inverse a function? Okay, and if I should, did I ask you to draw this graph here? No. If you draw this graph, okay, then your f of x graph, or your p of x graph, is going to be a decreasing function. Not so. This is a p. And your inverse is your log graph, which is p to the minus 1. So is the inverse a function? The answer is yes. Why? It passes the vertical line test. Okay, it passes the vertical line test. As you know, that the vertical line will touch this graph, will cut the graph at one point only. Okay? So it passes the vertical line test. And if they ask you what type of function it is, it's going to be a one-to-one function. So for every one x test, one y. Then the question says, in 4.2.4, the point M, which is 2 and k, lies on P. Is this pull down the equation of P of x? P of x is equal to a third to the x. P of x is equal to a third raised to the x. Calculate the value of k. So what do is I substitute M, which is 2 and k, into P of x. Remembering that's an x and a y. So k is equal to a third raised to the 2, which is 9. B. M dash. Remember that's M of M, which is a point on P. M dash is the image of M, which is basically a reflected point that lies on P to the minus 1, which is the inverse function. Write down the coordinates of M dash. So if it's a reflection or an image on P to the negative 1 or the inverse function, what do? We just interchange x and y. So M is simply 2 and a ninth. Therefore, M dash will be simply a ninth and 2. As we know, if it's reflected in the line y is equal to x, we just interchange x and y. Okay, next. In question 5. Question 5, we are given the graphs below for the function f of x equals, I think I just write it on the side here. So f of x equals 3 over x minus p plus q, whilst g of x is equal to 2 to the x plus q. What do you notice? That both has a q in it, which means to say it has the same value there. Both f and g has the same horizontal asymptote and a y-intercept on b. Okay? The point of intersection of f, A is the point of intersection of g and the vertical asymptote of f. Okay, as you can see, there's a line. Okay, so I'm just going to make this a bit smaller. Okay, so that's that. So the first question says, write down the value of q. As you can see, q is your y-intercept and your y-asymptote, your horizontal asymptote. So this is your value of q normally. So as it's going through 2, so your q value of course is going to be 2. So I can replace both with 2. Okay. Then we are told determine the value of p. So now we got f of x is equal to 3 over x minus p plus 2. Now to calculate p, I need one point that's lying on this graph. There's no point that's lying on this graph that is given to us. However, we know it's going through B. Now, B is your y-intercept of both f of x and g of x. Okay? Because g of x equation is already defined, we can now say the y-intercept, we let x equal to 0 of g of x. So g of 0 is equal to 2 to the 0 plus 2, which gives me an answer of 3. So therefore B's coordinate is 0 and 3. Okay? So now I'm going to substitute 0 and 3 into the equation of f of x, as we have now a point that's lying on this graph. Okay? That's the x and the y. So 3 is equal to 3 over 0 minus p plus 2. They get over the equal sign, so 1 is equal to 3 over negative p. So p works out to be negative 3. Okay. This pulls over. P is negative 3. That's correct? Okay, so P is negative 3. Yes? Sorry? X plus 3. Okay, that's correct. So negative times negative is positive. Yes, x plus 3 is correct. Okay, thank you. Any other confusion? No? Right, so the next question is 5.3.4. Here we are told that determine the coordinates of A. So for A, we already know what the vertical axis or asymptote is. That it has a vertical asymptote of x is equal to minus 3. So the coordinates of A is negative 3 and some y value. Can you see that? Negative 3 and some y value. So what do is, we substitute negative 3, we will substitute negative 3 and y into g of x. Why into g of x? Because the equation lies, or the point of A lies on g of x. Okay? So you say g of negative 3 is equal to 2 to the negative 3, which is 1 over 8 plus 2. So it's going to be 2 and 8. Or it's going to be 17 over 8. So therefore A is going to be negative 3 and 2 and 8. Okay. In number 4, the question says determine the equations of the equation of the axis of symmetry of f for the negative gradient. Okay, so that axis of symmetry, of course, is that line that's going through there, which is y is equal to minus x plus c. If they had said the one with a positive gradient, then I would have said y is equal to positive x plus c. Okay, that's number 4 now. So y is equal to minus x plus c. The only point that this graph is going through is that point of intersection of the two asymptotes. In this case, it's going to be negative 3 and 2. So remembering that's the x and the y. So 2 is equal to minus 3 plus c. So c is of course minus 1. So my equation is y is equal to minus x minus. Okay. Any confusion there? No? The question paper and his memo can be found in the description box below. Okay. Okay. So in 5.5, in question 5.5, We are now told determine x such that f of x minus g of x is greater than or equal to 0. I take that over the equal sign. It's the same as saying f of x is greater or equal to g of x. So in other words, it means the f of x graph is on top of the g of x graph. Okay, so as you can see here, the f graph is below here. However, it's only above from that point till there. Okay, so in other words, x must be greater than this value of minus 3, but less than this x value of 0. It's asking equal as well. Can the graph be equal on the asymptote? No. However, it is equal on 0. And then the last question, question 6. If the graph of f is shifted 2 units to the right, so I must subtract on the x there. Remember, it's the f of x graph, so is that one in question. So y is equal to 3 over. It's moving 2 units to the right, so I must subtract 2. So x minus 2 plus 3. Determine the equation of the shifted graph of f. So that remains the same. So the equation is y is equal to 3 over minus 2 plus 3 is 1 plus 2. Okay, so that is the equation that they were looking for in question 6. Okay. Okay, so we got basically 2 minutes left. That brings us to question 6. Okay. In question 6, we are told determine the nominal interest rate if the investment is received, if the investment receives R% per annum compounded monthly, whereas the effective interest rate effectively is receives 8.5% per annum. Remember the formula is 1 plus I effective is equal to 1 plus I to the m over m to the n. We'll stop here. Tomorrow we will conclude this. People, enjoy the rest of your day.